Alright, hopefully you made it through the first video and are able to now watch the second. You're going to see that these two videos aren't going to be too long. So I'm going to jump straight to this method. And again, we're going to use variation of parameters. We cannot use undetermined coefficients. Again, the reason why we cannot use undetermined coefficients is because of the function that it set equal to, tangent of x. So therefore, we're going to have to use variation of parameters. So what we know is that our function, our particular solution, should be of this form: u sub 1 of x times y sub 1 of x plus u sub 2 of x times y sub 2 of x, where y sub 1 of x and y sub 2 of x are going to come from the complementary solution. So in order to find the complementary solution, what we're going to do is we're going to use our auxiliary equation, where instead of having y double prime plus y equals tangent of x, we're going to go ahead and set this equal to 0 and use our auxiliary equation. So we're going to have m squared plus 1 is equal to 0. And you're going to use this, again, to find the complementary solution. So we're going to subtract 1 from both sides, and what we're going to take the square root of both sides. So we're going to see that m is going to equal plus or minus the square root of negative 1. And because we get plus or minus the square root of negative 1, this is really, our m is going to be plus or minus I. So therefore, we know that because we do not get real zeros, we're going to need to find an alpha, and we're going to need to find our beta. Well, our alpha is just going to be 0, and our beta is the number with the imaginary part, so it's just going to be 1. And judging or knowing from section 4.3 of using the auxiliary equation, we know that y is going to equal e to the alpha x times c sub 1 cosine beta x plus c sub 2 sine beta x. And so we're going to substitute in. So we're going to e to the 0 x, that's not an x, times c sub 1 cosine of x plus c sub 2 sine of x. And when we multiply, what we're going to see is that our complementary solution, so I'll say y sub c, is just going to be c sub 1 cosine of x and plus c sub 2 sine of x. So there's our complementary solution. So that tells us that our y sub 1 is going to be cosine of x, and our y sub 2 is going to be sine of x. Now, what we want to do, we already got part of our particular solution. We have our y sub 1 and y sub 2. What we need is u sub 1 and u sub 2. Now, in order to find u sub 1 and u sub 2, we're going to use the Cramer's rule with the Wronskian, where u sub 1 prime is equal to w sub 1 over w. And so what I'm going to do is I'm going to go ahead and write my w sub 1, which is equal to, and we said it was 0 f of x, which our f of x is going to be tangent of x. And then we have y of 2, which is going to be sine of x, times the derivative of sine of x, which is cosine of x. And so when we do the determinant, 0 times cosine of x is 0, minus sine of x tangent of x. And so I'm just going to get this equal to, and I'm going to go ahead and say that, sine of x times tangent of x is going to be sine squared of x over cosine of x. Now, my Wronskian is going to be pretty much my y sub 1 and my y sub 2. And then take the derivative of cosine of x is negative sine of x. The root of that we've already done, so cosine of x. And so the Wronskian here is going to be cosine x times cosine of x, which is cosine squared x, minus, but a negative, so plus sine squared of x, and that's just going to equal 1. And so therefore our u sub 1 prime is going to be just sine squared of x over cosine squared of x. Sine squared of x over cosine squared of x. Not cosine, but just cosine of x. And now, what we need to do is I need to find what u sub 1 is. And so in order to find what u sub 1 is, I'm going to integrate my u sub 1 prime. So I want to integrate this. Well, in order to integrate this, it's kind of hard right now. But so what I'm going to do is I'm going to go ahead and change sine squared to be cosine squared minus 1. Cosine squared of x minus 1 over cosine of x, which reduces to just cosine of x minus 1 over cosine, which is just going to be secant of x. Now, if I integrate this, then the integral of cosine of x is just going to be sine of x, but the integral of secant of x is you're going to have to use, in one of your calculus books, you're going to find all of the integration. And if you integrate secant of x, what you're going to have is just natural log of secant of x plus tangent of x. And that's what u sub 1 of x is. And so I'm just going to write that here. Now, to find u sub 2, we need u sub prime of 2. And so I'm going to do it's the Wronskian sub 2 times the Wronskian. And so I'm just going to go ahead and do my w sub 2, which is going to be cosine of x negative sine of x in the first column. In the second column is 0 in our function, tangent of x. Now this is a little bit nicer. So cosine times tangent of x, that's just going to be sine of x. And then the second part just going to cancel out. So it's just sine of x over 1. And so therefore, I need to integrate sine of x. And then when I integrate sine of x, I'm just going to get negative cosine of x. And that is going to be my u sub 2. And so I have my u sub 1 and my u sub 2. And now I'm just going to plug that in to my particular equation, and I'm finished. So my y sub p is equal to u sub 1, which is going to be sine of x minus natural log of the absolute value secant x plus tangent of x times my y sub 1, which is cosine of x, plus my u sub 2, which is just going to be negative cosine of x, times y sub 2 of x, which is just going to be sine of x. And so there's my particular solution. So that means the general solution is just going to be y equals my complementary, which is going to be c sub 1 cosine of x plus c sub 2 sine of x. And then if I combine all of this together, when I distribute that cosine of x, that's going to be sine cosine of x, but then minus sine of x cosine of x. So it's just really minus cosine of x natural log of secant x plus tangent of x, where this is just this simplified. All right, this is my y sub p, this is my y sub c.